we built visualization so that you can understand what the model is inducing. I think that was very unique.
In this week's episode of The Mixtape, I had the pleasure of interviewing Ronny Kohavi. Ronny is a computer scientist well known within the tech industry for a career that has spanned decades. He has made major contributions to machine learning as well as experimental design online. To an outsider like me, Ronny seems to have played a critical role in building the knowledge base and the infrastructure required to conduct huge numbers of randomized controlled trials online. These RCTs, called colloquially the A/B tests, are now a mainstay of business decision-making within tech. And while Ronny did not invent the RCT, he is no doubt at least partly responsible for helping scale up its practice and its adoption throughout the tech industry. He is the author of a new book entitled Trustworthy Online Controlled Experiments with Cambridge University Press. And in this interview, we discuss his career in computer science, tech, and his thoughts about causal inference and the experimental design more generally. My name is Scott Cunningham, and this is this week's episode of Mixtape, the podcast. Well, it is my pleasure to have on the show Ronny Kohavi. Is that how you say your last name, Ronny?
Yes, Kohavi.
Kohavi. Some of you know him. He's a legend, and this will be, for some of you, you'll be learning about him a little bit more, maybe for the first time, those of you from academic economics. So, thank you for being on the show, Ronny.
Thank you for inviting me.
For everybody present, Ronny, can you tell us your name and where you work and what your background is?
Okay, I think you said my name, but I'm Ronny Kohavi, and I have a strange history. I grew up in a combination of Israel, New York, back to Israel, and then went to California to Stanford to get my PhD. It's kind of an interesting story that while I was in Israel, I was all sort of into computers, and we had this club of kids with Apple IIs at the time, and I just started to work at a startup when I was just under 15 years old.
What year was that?
Well, you're aging me. This is like 1980.
Oh, really? Okay, 1980. All right. So 1980, you get a job at a startup. It's a computer company?
It was a software company, and we wrote sort of this, today I would call this like a database application generator. It was a form system that allowed you, had a UI that allowed you to like build forms and then have a database to back them up with reporting and everything. And it was sort of a strange time because, it was just the beginning of, the rise of the personal computer, and, companies were starting to understand how to build databases. And we had sort of the perfect tool, and it sold pretty well in Israel, including the Israeli Defense Forces. So I remember when I was 18 and I checked into the army, I was like, "You're using my system to check me in."
Wow. Wow. What were you programming in? What was your language?
We were programming in C.
Yeah. You learned that as a 15-year-old?
I learned that as a 15-year-old.
Yeah, I did too. My dad was a computer programmer, and I would write in Pascal games, those the text games, go north, go west, go east, and he would be doing stuff, and we had a IBM PS2 Model 30. That was ours that we had in the house.
Yeah, so I got an Apple II, and that's what I learned on. And then the company gave me a Unix machine home, which was this like giant machine that I had in my room, so I could work from home while I'm in high school.
Did you have a bulletin board? Did you have a modem? You were like doing BBSs and stuff?
Yeah. Yeah, so I had a modem. My Apple II in the early days had a tape that you would save to. And then I remember upgrading to a disk, and it was like huge. But no, that Unix machine was, had a hard disk and everything in it. And it was kind of a strange time because I was working for the startup, and there was one trip that he wanted to fly to California and try to sell it here.
Yeah.
And so he comes to my high school and says, can you spare 3 days so we can take the weekend plus 3 days to go to California? And I remember the teachers were freaking out. What's going on? Why is this student, flying out to California?
Wow. You were a prodigy. They must. So what? You were just like, you had some natural innate trait that made you good at, what was it? Programming? It was a programming?
I think, I loved programming. Yeah. I mean, it was actually, it started where, from a TI-58, there was this little programmable calculator that I had. That was my bar mitzvah present. I remember I was trying to sort of pitch, get me this thing because I'll enjoy it. And I was writing hours and hours and hours coding on this like little calculator that you could write, relatively sophisticated programs. I remember I had it play tic-tac-toe, and, I wrote these little games on it. But really, I think the leap was, when I worked at the startup and we started selling the software that was doing pretty well.
So would you say that you're a problem solver? Is that I'm trying to figure out what is the trait exactly like correlated with what that makes you so good at it at an early age?
I don't know. I think it's more of interest and passion that led me to read books at early age. When I then got to the Technion, I was like, I don't need to take data structures. I learned all this stuff on my own. I don't need to take operating systems because I, learned this stuff on my own. And I actually managed to convince some of the professors to let me off the classes.
They could tell.
There was a couple of them that were basically, they interviewed me for half an hour and said, yep, you don't need to take that class. We'll give you, the passing grade you need for your graduation.
Well, that was for grad school or undergrad?
This was undergrad.
Where'd you go to undergrad?
In a Technion in Israel.
Oh, okay. Is that tech school?
That's the famous tech school in Israel. And, so I managed to get my BA degree in 2.5 years because they let me off all these classes. And so I did it pretty quickly. Have to make up for the fact that I was 4 years in the Army.
Oh, yeah. Right. So then you go to Stanford.
Then I went to Stanford.
Real quick before I end this, were you ever all, super enamored with hacking and stuff when you were a little kid? Hack culture?
So there was a lot of the hack culture as it related to games. So we used to buy a game for the Apple II, and then myself and another person would sort of crack it so we could copy it and give it to all our friends.
Right.
So, I ended up, coming up with all these crazy tricks. We would just dump the whole memory and then figure out all we have to do is basically replay the memory and find out where to start, and you get the game. You didn't have to understand how they stored it on disk. There was this, amazingly complicated disk structure that allowed people to avoid being able to copy it. Something called half tracks. They would record, to move from track to track, you'd have to move the motor 4 times, and they moved only 2 times. And then, so if you were not on the right track, it wouldn't read properly. But we made this memory dumps, and then, I basically wrote this little operating system that was called HyperDOS at the time that would just copy the memory to disk and from disk really, really fast. It was the only thing it needed to do. So it was able to load and download, 10 times the normal speed that the operating system did. So it was a lot of fun.
Yeah, you were providers of you were Robin Hood, providing the public good. What was your hacker? What was your hacker name?
So there was actually, we were not using names at the time. It was this club that we got together on Fridays. A bunch of people like me. Remember, there was at the early days, there was not an internet. So we would just get together and figure out how to, break these games and, pass discs around and copy them.
Oh, yeah. Okay, sure. Well, so then you go to Stanford. So what year is it? It's like you graduate in 95. So this is like
so this was 91.
You get there in 91. Okay.
I got there in 91.
Stanford at this time, does it have a world reputation for computer science?
Yeah. It had
That's what it is. Like you would go to Stanford, you wouldn't go before you would go to MIT even?
That I don't know. I remember, if I remember correctly, I got into Stanford, but I applied to MIT and did not get into MIT. I think it's a high variance process. The whole application, it's hard to know, who reads your application and what recommendations they like. So I got into Stanford. He was, again, one of these PhD programs that was really good for people who wanted to learn on their own.
Yeah.
So you have to take some classes. You have to pass classes. I shouldn't say take. And you could either take them or just pass the exam at the end. And I think I just passed most of the requirements by taking the exams at the end.
What were you doing all the time?
Never attended much. What was that?
What were you doing all the time?
I was starting to learn how to do research. Reading articles, coding. This was the other thing, I was, because of my history of coding, I wrote a lot of code before coming to Stanford, and I was more of trying to do sort of what I think today is more of an engineering degree rather than a sort of a research degree.
Yeah.
And I got really interested in machine learning. And everybody was, you read these papers and there's the author's algorithms always at the top. And then, you see they were trying to compare, he or she was running, 5 other algorithms trying to compare it to. And it was really, really hard to compare to other people because you have to sort of re-implement the code from their paper. So I proposed to build a library that would implement all these common algorithms.
Yeah.
And it was called the Machine Learning Library in C++. And I, it was kind of a funny thing that, I went to agencies like the NSF and ONR, the Office of Naval Research, and I proposed we build this library. And I wrote these sort of grant proposals, and some of them got approved. And so I had effectively money to hire students to help me, build this library, which was kind of unique. In fact, one of the guys, I remember one of the people who approved the grant, then came to meet me, and he was shocked that he thought I was a professor there. And so we ended up writing this library of machine learning algorithms so that you could compare things to each other. So I wrote some relatively well-referenced papers on some ideas like doing feature selection. I think, 2 of my most famous papers are around doing feature selection and doing accuracy estimation. They each have like over 10,000 citations if you go to Google Scholar, which is, out there for people. Yeah. And the reason I could do that is when I implemented the feature selection, I could run it and see, does it help, naive Bayes? Does it help decision tree induction? Does it have, I worked on graph induction.
Oh, your ability to do that was based on this library kind of thing you had already made.
Exactly.
Oh, interesting.
Exactly. So we built this library, and it was amazingly useful because this was the first time you could write a paper that could compare to all these other things that were either re-implemented or interfaced. Like C4.5 was the decision tree induction of the day, and we built an interface to it. But we also re-implemented it, and it was kind of interesting because as we re-implemented it, I could do all these comparisons, and I would mail Ross Quinlan and say, hey, I'm getting a different result here. Here's the bug in your code.
Wow. What's your professors thinking? What are they thinking when you're doing all this?
My professor, it was kind of interesting. I worked with 3 people. Yoav Shoham was my main advisor. He was all into agents. There was Niels Nilsson, who was like this, figure in machine learning. He wrote the early book, which we laughed. He got everything right in the 60s when he wrote this book, except the name. He called it Learning Machines instead of machine learning. And then there was Jerry Friedman, who was one of the authors of the famous CART book, Classification and Regression Trees. So these were the three people that I worked with. It was kind of interesting because Jerry was in statistics, the other two was in computer science, and people were not talking to each other much at the time. So I had to like learn all the terminology from statistics. And this is a theme that I followed, by the way, for years and years and years. It's like sometimes you go into another domain and you have to learn the terminology.
Totally. Wait, but why did you go to stats?
So because I wanted to do machine learning, I noticed that, here was these articles like the CART book, one of the famous books on classification and regression trees. The four authors had amazing ideas, and, C4.5, which was the sort of computer science version from Ross Quinlan, it was very different. Like nobody was talking to each other. I felt, boy, this is an opportunity to combine ideas from both fields.
Yeah.
And so I think it was very, very beneficial. In fact, I think, Jerry Friedman from statistics probably had the most influence on how I learned, more statistics and did stuff that was kind of unusual at the time. And then we started to have these joint meetings. It was kind of interesting. There were some people that said, hey, we got to learn from each other. And we did that. But I remember, one funny thing is at some point I thought, hey, why doesn't MLC++ become sort of my thesis? And I remember, my advisor sort of consulted with some other professor and I said, this is just an engineering project. So I had to show research, and that's when I built some of the ideas around accuracy estimation, graph induction, wrappers for feature selection. And so another funny thing is when I finished,
it's kind of like the birth of machine learning as we think of it now, right? This kind of like merging of computer science with statistics. That's what you were sort of right there at the beginning.
Yep. Yeah, I was lucky to be there at the right time. Absolutely.
Wow. I did not put two and two together on that. So you graduate, and what was your ambition? Were you looking to become an academic?
So no. I knew I never wanted to be an academic, because I was in industry at the startup before. I knew I wanted to work in industry. But I was sort of going around the company saying, look, we have this machine learning library that I built, and one of the grants required that this be open source. So it was out there as open source. This was the early time of open source. And I was saying, why don't we build a product around it? And I remember, going to IBM, and they were like, nope, we are proprietary. We can't use any open source. And you can tell, by the way, that today is like completely different. IBM today it was like a big adopter of open source. But at the time it was like, nope, can't use open source. We can't use your stuff. And then I went to Silicon Graphics, and they're like, wow, this could save 2 years from the development of a product. And so that's what I did. I ended up going to Silicon Graphics to build.
That's like mid-90s. That's like
this is in 95. Yep.
Yeah. Okay.
And we basically built a product for machine learning and visualization, combining, the two things from Silicon Graphics. For example, there was a file system viewer, a graphical file system viewer that was a 3D flyover over the file system. So like you'd start at the root, and then you could, fly over and see the files. And this featured in Jurassic Park. There's this case where this little kid is like, oh, I know this is Unix. And she flies over the file system. And so we're like, boy, this is a great decision tree visualizer. Let's build the induction algorithm, take it from MLC++, combine it with this. And it became this sort of a really interesting combination of being able to visualize the models that you were building. We built visualization so that you can understand what the model is inducing. I think that was very unique. Because a lot of the time, once the tree gets more than a few leaves, nobody tries to understand what it is. And here you could actually fly over it and get all the statistics and see how it splits and what it chooses. And it led to some very interesting insights, especially interestingly enough, in bioinformatics. So there's a few companies at the time that were like, we got to have this. And so we sold, this was Silicon Graphics. Ultimately, it sells hardware. And because it was only available on Silicon Graphics, we were able to sell big machines to do machine learning on silicon graphics hardware.
Wow.
This was interesting at the time.
What were your client? Who were your clients? What were they using it for?
So that's what I'm saying. So it was basically bioinformatic companies were using it to try and understand, some gene patterns. We were everywhere. I mean, there's examples of banks using it, but
it was for
I think
prediction
bioinformatics.
This is like machine learning prediction analytics.
This is machine learning prediction. So you could build models, you can use it to classify. But the interesting thing was we were able, every model that we induced, we were able to show you visually.
Yeah.
And, that's what Silicon Graphics was known for, is the visualization. So we had,
how did you have that idea? What made you have that idea that would be like the app killer kind of to have it?
I think, so I wouldn't claim credit for that. I think, SGI hired me with the goal of bringing in MLC++ as a backend for machine learning and their knowledge in visualizations to combine the two to build a product. So we built.
Nobody had done that before. Nobody had been kind of blending.
People visualize things. In my thesis, I induced decision graphs rather than trees. And I found some software to visualize the graphs. It was called Dottie from AT&T. And so there are visualizations of the models in my thesis, and, I induced decision tables and I was building them. What we did here is one step further, which is to make it interactive. So, when you visualize a graph on a piece of paper, it was this ugly graph with too many nodes. When you visualize the decision tree, you could visualize the first 3 levels and then there's too many nodes. What was interesting here is that we built a tool that allowed you to sort of do this flyover. So if you were interested in, this age, this education, then the tree would expand and show you more and more nodes as you went over.
You feel like that helped these executives kind of understand what you were doing?
I think, it sold. I don't know if executives really got into this as much. I think the data miners at the time, the business analysts, they were able to better understand the data by doing this. I don't think it got to the level where, an executive would induce a machine learning model, fly over it, then change the parameters, build another model, fly over it. I think it was mostly done by others, but we were able to build cool models and show really interesting insights.
Yeah. That's amazing. What year was that?
So I was there in 95 to 98. The videos that you're seeing are around 97.
Wow, that's really cool. So when did you end up at Microsoft?
There's a long route to that. So after Silicon Graphics, I went to a startup in the Bay Area called Blue Martini Software, where the idea was to combine machine learning and to e-commerce, to try and, so you can build a store and then we can do mining to understand what patterns are out there.
Yeah.
And, we were fairly successful. I joined in 98, employee number 10, just so that you understand. In 2000, 2001, we IPO'd. So here's a startup that in 2.5 years, IPOs, a unicorn, we were worth like $3 billion. And we sold a bunch of the software that allowed companies to build an e-commerce site to sell something, but also use reporting and machine learning to find the patterns. And again, so I was involved in, real experiments trying to improve something on the website by, building a machine learning model to find patterns. And in fact, there was there's a competition, annual competition called the KDD Cup. And so we were able to release data from one of the clients and build a competition around it for KDD to predict who's going to purchase. And, we'd set up some questions, and it was amazing because, here's real data that we got, and you could see how. I'll share a problem that was very common, which is what we called leaks. This is when something sort of predicts the target. And so, but it leaks the answer. For example, if you're trying to predict if somebody is going to buy something, well, if you have access to sales data and there's a field which is taxes, then it's trivial. It's a leak, because if you know how much taxes they paid, then you know that they made a large purchase. And so it was interesting that in this competition, it was real data. There were all these leaks in there, and if you were trying to build a model and you didn't take the effort to remove the leaking attributes, you wouldn't do well in prediction, because during prediction time there was no taxes. It was always unknown.
Right.
And so it was actually, I was told that some companies spend hundreds of hours using their tools. There was I think, at the time there was tens of companies that competed, including the well-known SAS and, the company that monetized and built the commercial version of CART, classification and decision trees. But, it was kind of a real example of how hard it is in practice when the data isn't super clean for you.
Right. Was it common? Was it common, Ronnie, like at that time, for a computer scientist to be so deep into the weeds of working with data and data analytics? Is that like?
I think
back then
it was starting to get common. I mean, KDD became a conference in '95. So it was knowledge discovery and data mining conference. It's actually funny. I think it's KDD. Had some problems coming up with the names because some names were copyrighted, and
they're like, nobody's got KDD. You can't say
no, we were not allowed to use the data mining in the name. So KDD actually stands for knowledge discovery in databases.
Oh, machine learning was being trying. They were trying to copyright machine learning.
No, data mining. They were trying to use the data mining in the name. That was we were not allowed to use that, and so it became knowledge discovery in databases.
Okay. Well, so is this right, Ronnie? If I called you right now the father of A/B testing, is that mostly false or mostly true?
Yeah, I don't think that's true. I mean, I certainly don't think that. Let me put it this way. The theory of A/B testing was built by R.F. Fisher in the 1920s.
Exactly. Right.
So the statistics was known in the medical community. It was known by statisticians. I think what made a difference is the scale at which we started to run experimentation. So I think, Google and Amazon, I think, were the early company. I mean, the credit card companies were doing A/B testing for a while. As I was trying to find out, who was running A/B tests, there were some credit card companies that were running it. But I think the scale that we ran.
So walk me through the first moment when randomization is starting to cross your mind of having.
Oh, so that was even at Blue Martini. So we were, as I said, at Blue Martini, we were building these machine learning models, and we came up with insights about what we could do better. And then I actually remember the case. It was email. So we had an email system where we were emailing clients, telling them, hey, here's a product you should buy. And I remember the return on the email was just horrendously large. But it was done using sort of, I would say, simple estimates, because they were sending, some of our clients were sending lots of email. This is why spam became so common. I remember I was speaking to this VP, and he says, look, every time I send this email, we make $1 million. But so he was very optimistic, because he was sending all these emails, looking at revenue from the people that he emailed to, but many of them would have come to the store anyway. And so I was trying to pitch them to run a controlled experiment, figure out who you're going to mail.
So you immediately kind of were thinking about selection bias. Why is that? What is that? Is that something that you just immediately recognized, or is that?
Yeah, I mean, I think it was part of my stats that I learned at Stanford. I was aware of experimentation. I wasn't aware as I am today. I remember vaguely, you got to do a control group. And I remember, it was funny. I remember I said, listen, why don't we do a control group? And I remember proposing that we hold out, 10%, so we can assess the true value of the email campaigns. And this is, I remember the first time that like I couldn't convince businesses because they thought they were making so much money. And if they just held out 10%, they would lose 10% of revenue. Right. The person, the people there were like, what do you mean? I'm making $1 million. You're asking me to hold out $100,000? That's dumb.
That's been the obstacle, I bet.
That was a huge
because
obstacle.
if they don't believe that you need to do it, if they don't understand why you need to do it, then when you're asking them to do it, all they can think is, I'm losing $1 million.
I'm losing money. That was a huge obstacle.
Is that still an obstacle?
And I remember it was a very tough obstacle. Many of the clients were not willing to run any sort of a controlled experiments because they're dropping money on the table there. Yeah. But yet there was this feeling that they're way overestimating the return on the email.
Right.
Anyway, this was, I think, my first exposure.
What did you find?
We did run some control, and we found, for those that were willing to run it, we found that the return was much, much lower.
Yeah.
Right.
Did they immediately understand? Well, how much educating were you having to do while you're doing this? Of like, this is what I'm going to do, and this is what it means, and this. Well,
so remember, we were not embedded with a client. We sold software, and in fact, there even inside Blue Martini at the time, I don't think people appreciated this as much because will this sell more if we run a controlled experiment? And it felt more like this is for existing clients. If they want to overestimate, this is, by the way, I think this is a theme. If people overestimate something, there is no incentive for them to lower the estimate because their bonuses are tied to their claims. The money they claim, right? There's like, nobody wants to say, oh, remember last quarter I told you we made $1 million per email. It's really only 150K.
We lost $1 million.
Yeah. Well, you can't lose by email usually, but
right. Yeah.
But yeah, there was no incentive. It's like later on, when I worked at other places and I was telling people you have a lot of bots, there was like almost no incentive to remove the bots because it would remove traffic. And we couldn't claim we're the big site.
That's a real uphill battle.
That was a big uphill battle. And I think, that was my first exposure to sort of businesses having the wrong incentives because there was not this, measure of trustworthy results. I think, you'll hear me use the word trust a lot because this became a theme throughout my life where I was trying to pitch trust. That's also in the title of our book. Right. We were running controlled experiments that initially were not very trustworthy. We were making a lot of mistakes. And so
what's a mistake? Tell me an early mistake.
Oh, the earliest mistake was running controlled experiments and not looking for sample ratio mismatches. So SRMs. So this is very common. You run a controlled experiment, you randomize it, 50% control, 50% treatment, or, we usually are running smaller percentages, let's say 20-20. And then instead of getting the desired percentages, you're off. Instead of 50%, you get 49.5 and 50.5.
Okay. And you would just be like, let it go.
And well, we didn't know. We didn't do this check. We weren't aware that this is a problem in the early days. And so when you have a sample ratio mismatch, and I show this in my book, you tend to get very extreme results because the traffic that you're missing is usually highly biased in some way. It's the people who viewed 0 pages as an example, or it's the people that click too much, they got filtered out as bots. And so when you have a sample ratio mismatch, the result end up being either super good or super bad. Well, the super bad people, say, the idea is bad. The super good people tend to celebrate. Yeah. And so coming up with, just this guardrail to say, if you have a sample ratio mismatch, you cannot look at the results. I remember the first time we implemented this was at Microsoft. We implemented sample ratio mismatches. We put a banner at the top. You have a sample ratio mismatch, but we showed the results. And you could see people on giving talks and discussing the results of an experiment by ignoring the banner. It's like, this wasn't important enough. So we ended up blanking the whole scorecard if you had a sample ratio mismatch. You were not allowed to look at the results
Hmm.
unless you explicitly acknowledge that you have a sample ratio mismatch, and then we would uncover it.
Right.
I think this
Because
was
it was like this is what they call now p hacking a little bit, right? Like it's like a version of it.
no, I wouldn't call this p hacking. We're not
I
trying.
just think of p hacking is like this. I think of p hacking is like this, where the incentives are in place for you to, kind of go beyond what's kind of experimentally valid.
I'll talk about p hacking in a second. I'll give you better examples, and some of them are in this KDD upcoming article that's going to be this August, where we sort of look at intuition busters. But I think SRM, to me, was a surprising step in recognizing not just sort of a problem, but how often it happens. So, so when we implemented SRMs, we realized, boy, this is like happening a lot. It was like 15% of experiments have this sample ratio mismatch, and each one was a huge pain to debug because, is the randomization usually isn't broken, right? You tested it. It's something else in the data pipeline on the way. It's some filter. It's some traffic that gets from the other side. So there's actually a paper published a couple of years ago by my team on diagnosing sample ratio mismatches. And they share that, even at Microsoft, when we had experiments running for, a dozen years at Bing, we still get sample ratio mismatches once in a while. And in new organizations, you see that a lot. Recently, and this is why it's interesting, because when you look at vendors, companies rarely implemented this check. Like I remember going to Optimizely and say, look, you guys are not doing sample ratio mismatch tests. You should do that. And it took them years to implement that. Like I was at a point where we were at Microsoft, we were doing experimentation for the product teams, Bing and Office and, Xbox, Windows, all those. And meanwhile, the marketing people, they were using Optimizely because it's easy, it's WYSIWYG, it's beautiful. And at some point we were looking at some of the results and we were horrified to see all these sample ratio mismatches.
Right.
And here are people making decisions where the result is invalid and the company doesn't recognize it, or the software from the company. So I think that this is probably the best example of a guardrail that everybody needs to build.
And you built it into, it sounds like you built it though into not just as a concept, but like software. Like
we built it into the platform, and that's everybody has to do that. So any provider of A/B testing needs to have a check for sample ratio mismatch. And if it's violated, if the probability is low, it's like, getting 49.5 and 50.5 and you're supposed to get 50-50. And when you have 1 million users, that's like winning the lottery. That shouldn't happen to you.
Got it. So it detects the probability of an SRM that would occur under this randomization. And then it tells you this is not, something's wrong. Right. Something's wrong with the randomization. And now,
so that's the point. It's usually not with randomization. Sort of is a hashing algorithm. It's gonna work. The problem is that the data pipeline at some point removes data. For example, fraud is typically removed. Bots are removed. I mentioned this statistics that people don't realize. At Bing, 50% of the traffic is bots.
Right.
And so if you don't move the noise, you lose statistical power. You want to remove all this noise that is not coming from humans. And so usually in the data pipeline phase, there is something that removes data. And if it generates the SRM, your results are invalid. A lot of the times it's a campaign coming from the side. Marketing would sort of throw a campaign and it would only go into the control or the treatment, and that would create the SRM. But this campaign is very biased because, whoever clicked through from some ad is going to be very different than somebody who came to the website. And so this creates huge biases.
Yeah.
And, unbelievable results.
So when did you notice you were like, the A/B testing is probably about to become a major part of my life? Was there
so this was very, very explicit. So, I'll say I'll credit Amazon with teaching me more about experimentation. When I got to Amazon, and this is why, I give credit to the Amazons and the Googles of the world. Amazon was already running controlled experiments when I joined. There was a system. I helped improve it, but it was called Web Lab, where we were already running at Amazon controlled experiments when I joined, and we improved it and we started to scale it. But I think the big difference for me was when I came to Microsoft. I came to Microsoft to build machine learning models for understanding user intent in Office. This was what I was hired to do.
What year is this?
Huh?
What year is this?
This is in 2005.
Okay. All right. Sorry. Keep going.
So I'm supposed to, build this group that builds machine learning models to understand user intent and help them. And the VP that hired me, Kai-Fu Lee, goes on sabbatical. Microsoft has this concept of you get a sabbatical after N years. He doesn't come back. He goes to Google. And so people come to me and say, okay, he had this vision. We are not going to execute on it. We're going to break up the team. The whole division's gone away. I was hired at something called the partner level, which is, people are supposed to be, similar to a law firm, the top echelon of the company. And they were like, we don't know what to do with you. Take 6 months, think about what you want to do. And we'll see if we want to do it. So I said, I'm going to build an experimentation platform.
Wow.
Because in a few months that I was there, I noticed that nobody was running controlled experiments.
Yeah.
We were shipping all this stuff. We were updating, MSN was a live website. The Microsoft.com was a large website. Nobody was running controlled experiments.
It's kind of historical. I mean, Fisher and Bristol started the Rothamsted experiment station. And that's
right.
Where randomization inference anecdotally came from, was from that. It's neat. You're just following in the footsteps of all these experimentalists in 100 years. That's really neat. So you come back, you tell Microsoft, I'm going to start an experimental design center at Microsoft.
Right.
What do they say?
Nobody understood what I wanted to do. It was a couple of months where people we don't do this. We know how to ship software. We're the best at shipping software. Why would we do something different?
Yeah.
So I basically, cobbled a few resources. And I remember the first year.
Well, wait, Ronnie. Okay. Why are you betting on experiments? Tell me.
I knew it worked. So I had the experiment that I ran at Amazon.
Yeah.
And I was humbled to see that half the ideas failed. I remember this, there's this statistics that, I had several teams at Amazon, but, I also had the Web Lab team. So I was responsible for the team that ran the platform at Amazon, and I was head of data mining and personalization. So in personalization, we were trying to improve the algorithms, and I saw lots of failures.
Yeah.
We were coming up with all these nice ideas. And I remember at one point, I think this was the epiphany for me, was I said, let's just see what percentage of our ideas are successful.
Yeah.
And it was just around 50%.
Yeah.
And I was horrified. I'm like, when you work with the teams, everybody feels that, everything they do is great. Uh-huh. And, we celebrate the release.
Right.
And on my team, when we started running experiments, we realized we're failing so often. So I knew that this thing is going to be humbling. And I came to Microsoft. Listen, this is the interesting part. I came to Microsoft and I said, look, we're shipping a lot of stuff. We celebrate, ship it. I'll show you this thing. I have to change the background on this. Well, let me not do it here. Microsoft gives a Ship It award every time software ships. And it says every time you ship, you make progress. It doesn't say if you improve. It just says, the incentive was to ship. And I came and I said, listen, if we evaluate things, we're going to find out that 50% of the ideas are failing, because that's what I observed at Amazon. And the response was unbelievable denial. The first response that I'm hearing, we have better program managers here.
Yeah.
They were thinking that 50% is impossible. The Amazon program managers must be idiots, because we're shipping good stuff. Now, I at some point later on, I published a paper and I showed that it's not even 50%. It's only 30% of ideas at Microsoft, about a third,
So you do have better product. You do have managers. It's only 30, not 50.
That are worse. Yes, on average.
Wow. You think about like the mythology of Steve Jobs and how he's like, I don't run focus groups. I know what people want. It's like, I bet you that.
Well, first of all, that's not true. I mean,
Is that not true?
Apple does a lot of internal testing and dog fooding of their products. And it is true that he was more of, I come with the ideas, everybody executes.
Okay. So that kind of ethos is a little bit of his cowboy mythology a little bit.
And I think, there's some products for which this works. And I think, if you look at innovation over time that happens for search engines, for assistants, who's going to win long term? Is it Siri or is it, Alexa? I'm betting more on the Alexas of the world that are just going to incrementally improve with the data over time.
Right.
So
I'm not sure about that.
Mine's unplugged. I was like, I'm glad mine's unplugged.
So I do think that, and this is one of our papers, we said there are sort of areas where experimentation fits well. Yeah. And there are areas that it doesn't. And, if you're iterating on a regular basis quickly, that's where experimentation works. If you're building something that releases every 5 years, it's not the ideal space for experimentation.
Why? What's the big picture of explaining why those two events?
Well, so you need to get this feedback, right? You want to be able to be in a domain where you can iterate and learn from it, right? There's this cycle of you get an idea, you implement sort of a minimum viable version of it, you try it out, you learn, and then you repeat and iterate. Now, if your product is releasing, I'd say every couple of weeks, the standard Scrum methodology, then you're in great shape, right? Because you release stuff every 2 weeks. And
it's like you're using the RCT to optimize. Like,
you're using the RCT to learn and change the product map. Now, if you build a product map that's going to be, here's what we're going to do over the next 3 years. Think of Windows Vista, right? It's a 5-year release.
Yeah.
There's no opportunity to get feedback until the last year when they go out to, insiders and do some alpha and beta testing.
Yeah.
Right. And by then, the software's been QA'd and everybody's invested. Right. And there was actually research showing that, big releases of Office, most of the features did not improve the user experience. So there was some of that being done at Microsoft at the time. But I think the real difference happens when you're able to change the release cycle. So, for example, at Microsoft, there was a big change to go from releasing Office every 3 years to releasing Office every month.
Right.
And when you release Office 365 every month, you're in the experimentation world. You can now, every one of these monthly releases has hundreds of features that are built as experiments. And then you get the data and you can make a decision about whether to, this idea is good or bad and how we incrementally improve it.
Let me ask you this. I have two questions and then it's top of the hour. If the part of what, so I'm at a business school and we at Baylor, like every other school in the world, has started these masters of data science or business analytics programs, and so I was just curious if you could go in, right, and say, I would like to, design elements of this curriculum or of this 1 year data analytics, right?
Yeah.
And they gave you a blank check and they were like, all right, do it. What are you going to do?
My recommendation is to give people sort of a real problem where the data is dirty. I think most of the data that we see out there in school, the data that, I grew up on something called the UCI, the UC Irvine repository. It was a large repository of machine learning problems. They were all super clean.
Yeah.
Somebody did all the work to clean the data. And then I remember when I ran this KDD Cup, there was, the data was real.
Yeah.
And so you learn about things like leakage and things like that. So I think this to me is the recommendation for programs is pick some real problems real problems in the real world, try to solve something from end to end. Don't focus. I mean, there's this joke, that, when we build machine learning models, we think of the machine learning as the 90%, but it's really the 5%.
Yeah.
Right. And so you end up spending most of the time on the data processing.
Totally. Yep.
And then, the joke is that you spend, 80% of the time on the data processing, 5% of the machine learning, and then 50% explaining to others why 80% of the time took so long.
Right. Yeah, no, I have a lecture I give called The Hidden Curriculum that's all about the importance of that 80% time period, that being crucially important. Okay, that's really great. All right, so second question. Now you get to go into a high school, an ordinary high school, not in Palo Alto, just random part of the country. And these are kids that literally they don't know what's out there, like that, right? And you can help expand their horizons and give them, and really at the same time kind of, advance their education. What do you think that what do you think would really, really, really be an impactful educational experience for like a 11th or 12th grade kid?
Okay, I'll tell you what I think. The hierarchy of evidence. So I don't know how much you're familiar with this, but there's this sort of a hierarchy of evidence where people say, if you hear some anecdote, don't trust it. And then if you see an observational study uncontrolled, you can trust it a little bit more, but not much. And then at the top of the pyramid are these controlled experiments and multiple controlled experiments. I think giving people at an early age the ability to read a piece of paper and then critique it as this is not something that I would trust because it is based on an observational study, I would trust it less. I think being able to teach people, and this should start at high school, but I think it goes, all the way to, college and university.
Yeah.
Many of the publications that we see out there are incorrect.
Right.
And, I have this talk that I give out on famous results that were later on debunked.
Yeah.
Papers that were cited 1,000 times based on an observational study. And then they sort of realized that, when they run the controlled experiments, it's in the other direction.
Right.
I think this is one of those things, the ability to read a piece of news and understand if you should trust it because it is based on a controlled experiment, or it is based on, some doctor saying, hey, I had 5 patients and all of them got well when I injected them with this magical drug.
Right. Yeah. Trust, the name of your book, Trustworthy Online Controlled Experiments. I can see now. And even circling back to the challenges of even a firm like Microsoft at that early stage, not being able to understand what you were doing, how just at an earlier age, introducing that pyramid.
Right.
Just interested in introducing that pyramid, that visual pyramid, even, that visualization of it. It's great. It's a great idea. Yeah. Well, it's a real pleasure, Ronny, to have you on. I wanted to kind of conclude one thing. You teach now a lot of stuff on A/B testing at ScholarSite. Can you tell us a little bit about who that's for and what it's been like for you and for the students?
Yeah, so it's actually been surprising. I would say when first of all, when Cambridge approached me to write a book, I was like, this is too niche of a topic. Nobody's going to buy it. And obviously, the book did a lot better than we expected. And, I've seen a lot of people sort of in surprising domains that told me that, they're able to influence their bank or this, company doing something unrelated to what I think is, sort of the classical, e-commerce. So when I first set up the class at ScholarSite, again, we thought this is going to be a fun class to do. And we already did, 4 cohorts. Some of them we had to stop registrations because they got full, because we want to keep the class small. But I was very surprised by the breadth of the companies that are sending people to learn.
Yeah.
If you go to the website, you'll see, of course you see the Googles and the Microsofts, and Apple is sending some people. Again, we talked about, is the culture right for that? But companies are interested in learning more, and you see, Disney sending people, Nike sending people, Anheuser-Busch, British Petroleum. These are people that, Peloton, these are Fidelity. These are companies that are, I wouldn't say are sort of the classical, software builders with a website that they can iterate on.
Right.
And so it is interesting to see that
but it's not just the website.
Exactly.
I mean, it's right. It's like, it's not just about websites. It's about, true evidence-based. You could have, like, using the hierarchical thing, you could have evidence-based reason.
Oh yeah, I mean, look, evidence in medicine
uses anecdote. It uses anecdote as the evidence, right? Like there's when you combine business analytics or business decision making with the art, with a culture of like, we're going to randomize, it's a real game changer. It seems like it would be, or it could be.
Now you still need, if you look at my chapter 1, there's just sort of these things that you have to believe in, the tenets.
Yeah.
And I think it is important to recognize, like, if you are working in a domain that doesn't iterate fast enough, it's really hard to use experiments.
Yeah.
I think there are some necessary things. I mean, you have to believe that you're not going to create a 3-year roadmap and execute it, that it's a forking path, right? We're going to try this, and based on that, we're going to decide.
Yeah.
I think that's a cultural thing that has to be adopted, and some companies choose to do it and some don't. And, and by the way, I respect some of the things at Apple where they do execute in a certain way that's different than the Googles and Microsofts and Amazon. Yeah. And it's working for them. I don't necessarily like that. I believe in empowering the organizations, telling them, here's a metric that we want you to optimize, letting them innovate and prove through experimentation that they're moving that metric.
Yeah. It's awesome. So you're going to do another class at Scholar Site?
Yes, we had 4. We're doing another one in late August.
Cool. All right. Well, good luck with that. Well, Ronny, it's so much fun getting to meet you.
Absolutely. I enjoyed it.
It's an honor. All right. You have a good day.
You too. Bye-bye.